Popcorn. A snack we all love at the movies, during study sessions, or while binge-watching YouTube. It's crunchy, fluffy, and somehow comforting. But have you ever wondered why this tiny, rock-hard seed suddenly explodes into something light and edible? Is it magic? Is it chemistry? Or is it pure physics at work? Today, we're diving into the unseen science of popcorn, and by the end of this video, you'll never look at popcorn the same way again. Every popcorn kernel looks simple, but it's a tiny pressure cooker. Inside, it has three parts. 1. Pericarp, the hard, airtight outer shell. 2. Endosperm, starch and protein, which later turn fluffy. 3. A droplet of water, the hero of the story. No water, no popcorn. Kernels that are too dry just stay hard, no matter how hot they get. When heated, in oil, a pan, or a microwave, the kernel's temperature rises. At 100 degrees Celsius to 112 degrees Fahrenheit, water inside begins to boil. Normally steam escapes, but the pericarp locks it in. Pressure builds and builds. By 180 degrees Celsius, 356 degrees Fahrenheit, the pressure can reach 135 psi, more than twice a car tire. Finally, the shell can't take it anymore. It cracks. This isn't a gentle opening, it's an explosion. The water inside is superheated, hotter than its normal boiling point because of the pressure. The instant the shell breaks, pressure drops to normal air levels. All that energy releases at once. The superheated water flashes into steam in milliseconds, blasting the sulfun starch outward. The starch, now gelatinized and stretchy, expands like a balloon. Then it cools rapidly, hardening into the fluffy shapes we eat. Each piece looks unique because each explosion happens chaotically. So why doesn't rice or wheat explode? They lack the same strong shell. Steam leaks out before pressure can build. Popcorn's pericarp is uniquely engineered by nature to hold in steam until the dramatic burst. Ever noticed unpopped kernels in your bowl? That's usually because they've lost water over time. The ideal popcorn kernel has about 14% water by weight. Too little, and it won't pop. Too much, and the popcorn turns chewy. That's why some commercial producers even add moisture before packaging to guarantee more pops per batch. And that iconic crack. It isn't the shell splitting. High-speed studies show the sound comes from the sudden release of pressurized steam, a tiny shock wave. In a sense, every kernel is a little volcano erupting in your kitchen. When you watch popcorn pop, you're seeing physics live. Heat transfer from stove or microwave into the kernel. Phase change, liquid water to vapor. Gas laws, pressure builds as heat rises. Thermodynamics, stored energy transforms into expansion. It's not just food, it's edible physics. Popcorn isn't new. The oldest kernels found are over 5,000 years old. Native Americans ate it long before movie theaters made it famous in the 20th century. What feels like a casual snack actually has ancient roots.